Okay, we're going to do practice problem 3 from the website here, and I'm going to walk through as I would do it. So first thing I'm going to do is to make a little table as to what is happening. So the problem reads, a person is initially standing still at 0 seconds at x equals 0, and then at t equals 1 they walk in the run, that is, in the negative x direction at minus 3 meters per second for 3 seconds. So from 0 to 1 second, they're standing still. From 1 second to then 3 seconds later, which would be 4 seconds, they are running with the velocity, which is negative because we're going in the negative x direction, 3 meters per second. Then the next step is for the next 3 seconds after this, which would be from 4 seconds to 7 seconds, the person walks in the negative x direction, so walks with the velocity of minus 1 meters per second. Notice it's slower than it is for running. And finally, for the last 2 seconds, which would be from 7 seconds to 9 seconds, the person runs in the positive x direction. So running v equals 3 meters per second. That's positive. Okay, so what we're going to do is we're going to go through each of these one by one, starting with the position. So I'm going to first draw an axis. Now when you do this, some care has to be taken to make sure that you get all the points on the page. Now I know the answer, I have the solution, and I've worked it out, so I know how to get all the points on the page, but when you are doing this on your own, sometimes you may go off the page. But I know what's going on. So we're going to draw a graph where x is on this axis, the vertical axis, and time is on the horizontal. And I noticed that I'm going to need to go at least to 9 seconds, because after that the person is stopped. So I should write that down: from 9 seconds on, stopped. Okay, so I need to include at least, say, 10 of these. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And obviously graph paper would be better, but I don't have graph paper here. And then, because I'm going primarily backwards in the negative x direction initially, I'm going to mark those positions off. It's going to be easiest if I do this in twos, because that's what the work with space. So I'm going to do minus 2 meters, minus 4, minus 6, minus 8, minus 10, minus 12. And of course in between is 1, 3, 5, 7, 9, 11. All right. So the first thing I'm going to do is to do standing still. So from 0 to 1 second, the person stands still. This is definitely the easiest part here. So their position is at x equals 0. It stays at x equals 0. All right. Now they run for 4 seconds, 3 seconds, but that's 2, 3, 4. It's this time interval here at minus 3 meters per second. And so what this means, in 1 second then, they go negative 3 meters. So I'm going to do this actually in a different color and then draw the line in the end. So if I go in 1 second, they go -3. So 1 second, 1, 2, 3. That's -3 meters. And then in the next second, 1 more second, they go 3 more meters backwards, or in the negative x direction. And now they're at, notice now they're at 6. And at the end, we're going to end up at 9. So the next second, we go like that. And now I can go ahead and draw my little line here because we're going at roughly a constant velocity, this problem. Sorry, my lines aren't very good. Okay. Now, from 4 to 7 seconds, we walk in the negative x direction at 1 meter per second. So in 1 second, we go 1 meter backwards. So in 1 second, get this right, this is 1 second, I go 1 meter, which would be right here. This corresponds to 10. And I'm going to do this for 3 seconds. In the next second, I go another meter backwards, so I go from 10 to -11. And then in the last second, I go 1 more meter backwards. All right. Now, the last part where we're actually moving is for 2 seconds, we go forward now at 3 meters per second. So forward, I start here, and in 1 second, which is 8, I go 3 meters, so I'm going to go from -12 to -9 because that's up 3 meters. And I'm going to do that 1 more second, so for a total of 2 seconds. So if I can get this right, like that. Okay. And now if I draw that, that's where I am. And if you look at that, my graph isn't perfect, but it looks like I'm at -6 meters, and that's actually correct. If I did it very carefully, I get it correct. And then once I stop, I don't move again. All right. So this is the position curve. If you were to look at this, if I hadn't given you the words, you could understand what's going on by looking at what we call the slope. So here, you're not moving, the velocity is 0. Here we're moving backwards, and you'll notice we're moving backwards quickly. Over here we're moving backwards, but we're moving backwards slowly. So this is the run, and this is the walk. And then here again we're moving forwards, it's going, the x position is increasing, and here we are running again, and here we're stopped. Okay, the next thing we're going to do is velocity.